virtual memory versus memory. And Nate, you started to talk some about this in the critical path, but a lot of people use the terms interchangeably, and it turns out that in compute world, they are not interchangeable. So memory, like RAM, is the physical devices that store memory on a machine, right? So like the DIMMs or SIMs, if you're really old, that store stuff used by your computer, that's memory. But it was very expensive. And so what we started doing is using disk space to supplement that. And that's what swap is. So swap is a disk device used to supplement memory on your computer. When you supplement it, that gives you additional capacity, right? So virtual memory is your RAM plus your swap, right? That's your system's total virtual memory.
Right.
Now, in reality, like disk-based storage for stuff is not as good as RAM because it's slower. You have to get data in and out of the disk IO subsystem. So you have like all the disk IO overhead for getting data in and out of your swap space. So it's preferable for computing to store data in RAM for your applications because then the computer, like the process when it needs it, can readily access it. There's not a lot of time lag between when the request is made and when it's serviced back by your operating system kernel to that application. Whereas if you have a request that is for a piece of data that's on swap, instead of the operating system kernel retrieving it from memory and passing a memory address to the application, it instead is okay, we're going to do some disk IO. We're going to swap in our data to memory. And then once we have it swapped into memory, we can provide the memory address to the process that requested it. Right. So all that additional transaction stuff makes swaps slower, significantly slower. That's also why people are always like, don't put things on swap. Because if it's something that's used, we know that accessing it takes longer.
Right. Right. Now, obviously, that's a different world than when everything was on spinning disk, because disks are much faster, but there is still overhead to that, which is what Scott was just describing.
Right. Even if you're using SSDs for your swap, it will be less efficient and take
Right.
longer to resolve memory requests than if you use just natively stored in RAM. In the chat of our stream. Oh, by the way, if you're a deferred guest, please feel free to leave us. JScar asked what our take was on having swap. Like, do you even need it? I think the answer is largely yes. Having it doesn't hurt things generally, but there are places where you don't use it. For example, cloud instances very rarely have a swap. Though the reason for that is actually a compute and cloud architecture thing, not necessarily a Linux thing, right? So in cloud world, when you add a disk or you allocate some disk to your machine, who knows where that lives? It's out there in some cloud, which might
Hmm.
be in a storage zone or something else. There's also not a lot of like guaranteed consistency in that backing storage. If we're in a situation where we need to retrieve a piece of data from swap to service a process request, what happens if the cloud storage where your swap is just happens to be extra slow that day? Now your like swap ins from that extra slow disk take even extra more time. In the early days of cloud, where things like weird latency and other stuff happened more regularly, they just said no swap for
Right.
machine. And that is kind of a tradition we carry on today, even though disk backends for cloud providers have gotten substantially improved over the last 10, 15 years.
So the answer is it depends.
Right. It
Usually,
depends.
yes. Sometimes, no.
Well, that kind of leads into like how is swap used for things, right?
Right. Right.
And I think the other question that kind of falls in there is if I was going to have a swap space, how big would I need it to be? And that is also an it depends. So, for example, if you're a laptop user, you probably want to swap that's close to your amount of RAM because swap is used for things like suspend operations for laptops. RAM state, and we persist it out to the swap space. And that's how we can then keep the machine cold and not use a bunch of power to maintain the charge in the RAM modules and keep the memories going. If you're not a laptop user, or you're a laptop user but you don't really care about suspend operations, maybe you don't need that. You know, first you probably don't need something equal to RAM. It's going to be less than that. It depends. I think the really key thing is the laptop use case. If not a laptop use case, you get a lot more flexibility in choosing how much swap.
Right.
The other
Right.
thing
There used to be good rule of thumb like percentages you would follow. If you had this much RAM, you should have this percentage of swap. If you have that much RAM, and it would change based on how much RAM you had. But now a lot of it is workload specific. A lot of times, what you're doing is looking into the workload, find specific requirements, and then if so, you should follow those. If it doesn't, then you're going to want to try to follow that rule of thumb.
the other thing to keep in mind is that you can always add swap space. So you can
Right.
add new disk devices. Nate, in your lab, you're using a logical volume managed swap device.
Hmm.
Just like slap more volume group space into that thing. Now it's bigger. Or add another logical volume on another volume group or additional disks. And now that could be mixed into your swap organization.
Now,
Um,
that does become more of a problem if you're running physical disk on a physical machine. Virtual disks are different, right? You can add more virtual disks and boom. But you'd have to do some like file system resizes if you didn't leave free space on the disk if it's a physical volume that you're trying to put swap on.
yeah. So, or if it's like you're connected to a SAN, you can
But
have
yeah,
SAN and
yeah.
a logical volume, right? That's actually one of the early things for swap was that it could be aggregated together into kind of a homogeneous device, just like we do today with logical volumes, where we take all this disparate disk space and we make it a single addressable unit.
Hmm.
Swap kind of the same way. So you can activate multiple swap spaces. They'll be used by the kernel. There's actually another parameter on swap spaces called priority that tells the kernel which one to prefer over others. So you can mess around with like
Yeah.
how the thing is. And if
Yeah,
you're real,
you could have seen that in the swap on command I did. I didn't highlight it, but the last column said priority and there was a number. That's how you can tell where it goes first and last.
if you're desperate for more swap space, Nate, what could you do?
If you're desperate for more swap space. Oh, are we talking about the kludgy thing I was going to do initially? Yeah. You can make a file full of zeros and then you can format that just like a virtual disk. Like you might do this for virtual machines, for example. You make this empty file and then write the swap file system to the file because Linux will let you do that. And of course, you can activate that as swap. However, that's going to perform even worse than just a normal swap on disk because it not only has disk IO to think about, it's got file system and LVM in the middle there to overhead for all those various layers before it gets down to the disk. So it's quicker if you put it direct in the LVM or direct on disk.
If you're desperate, you could do that, not the preferred or recommended method.
We used to do that to appease our Oracle database administrator when his ridiculously overspec system, Oracle told him, you need more swap. Well, the disk is already fully allocated. How am I supposed to give you more swap? So we would make him a file and add it to swap.
I see some chat, and the participants are like thinking in the right direction. So regardless of like how much swap and other stuff, like maybe we should talk about what swap is used for. So, because it's part of the virtual memory subsystem, it's used to supplement system memory. There's RAM and swap together as virtual memory. And what happens is the kernel will kind of scan through RAM looking for RAM that it could send a swap space. And it looks for unused things in memory. So it's typically not going to pick something that's active or frequently active because if it used that thing and sent it out to swap, then it would just have to pull it back in again the next time somebody used it. So it's looking for inactive pages of memory to then swap.